So, ang mapaprocess sa retention time na 13.5 minutes na dry ore ay multiply mo na siya. So, 10.07 times 13.5, ang lalabas dyan ay 136 metric tons. Yan. Kailangan naman natin kung computin yung hindi kasi given yung density ng slurry. Makikita natin kung, ayun, yung slurry nga pala ay yung nagpakompress ng solids and water. So, ayun, galing doon, compute natin yung density ng slurry. Assuming na hindi nagre-react yung copper or pati yung water, so yung volume ng slurry ay equal sa volume ng solids pati volume ng water. Hindi naman sa atin i-specify kung ano yung mga volume na to, pero sinabi sa atin yung percent solids, 30%. Tapos binigay din sa atin yung specific gravity ng solids. So pwede natin gamitin yung relationship na mass ng slurry over density ng slurry equals sa mass ng solids over density ng solids plus mass ng water over density ng water. Ayan, so yung density naman ng water ay 1.0 metric tons per cubic meter. Since solid ay 2.7 metric tons per cubic meter. Ayan, mag-assume tayo na 100 grams ng 100 metric tons ng slurry. So, 100 metric tons ng slurry equals sa yung mass ng solids ayan. So, yung X, 35. Ayan. So, makukuha natin yung density ng slurry, which is 1.23. Tapos, sabi kanina, itong 136 metric tons na to ay dry. So, kung 30% to ng slurry, ibig sabihin, ang mapaprocess na mass ng slurry ay 453 metric tons. Tons ng slurry. Yun, makukuha na natin, gagamit ito, makukuha na natin yung volume ng slurry na mapaprocess. Yun kasi ang aim natin kasi parang hahati-hatiin siya dun sa mga cells na yun ang kailangan natin hanapin. So, ang volume na ang volume dito ay 453 over 1.23 equal yan sa 368 cubic meters. Yan ay pag na-aerate na. Paano kasi pag na-aerate na, syempre, naglulutangan na yan, naglulutangan na. So, initially, sabi daw, before ma-aerate, 85% pag na-aerate na, 85% nung cell, ang laman nun, slurry daw 15% air. So, ang original na nilalagay mo talaga sa isang cell ay i-divide mo by 0.85. Ayan, equal yan sa 43 cubic meters. Ayan, dito na tayo sa yan, tingnan tayo sa susunod na table. Average shell count per bank. Kasi di ba sinabi natin kanina, ang standard cell size ay 14.15 cubic meters. So yung number of cells na kailangan para matapos yung procedure ay 433 over 14.5. So 31. Ano yan? 30.6. Approximately 31 cells. Dito kasi, ang makikita nyo dito, kung ito yung copper, wala kang makikita 31. So, Per bank naman yan, pwede kang magdalawang banks, tatlong banks. Depende kung parang kung ano yung compatible. So dito sa 31 cells, kung titignan natin yung copper, ito na yung parang allowable from 12 to 17. So pwede kang magdalawang dalawang banks. Okay, pwede kang magdalawang banks. 16 cells each. Yan. Kung basic makikita nyo naman, sobra ng isa, okay lang yun para parang extra lang siya. Ayun. Pero yung hinanap sa 31 cells, yun. Sa ganung kahabang equation, ganung kahabang sa solution, yun ang ibigay sa 31. Ayun, yun lang naman.
Yun na po yung flotation. Now we are open for questions and clarifications if you have. Any questions?
Clarify ko lang, di ba, compute 2 banks, tapos 16 cells each. Pero 31 lang naman yung kailangan natin. Di ba pwedeng 15 cells yung isa, tapos 16 cells yung isa sa isang per bank? Okay lang, kaso naman, parang sobra okay lang naman kasi mag-sobra. Kasi parang allowance siya. So, pwedeng hindi talaga 433 yung laman, 433 cubic meters yung laman ng isang cell. Pwedeng bumaba dahil may sobra ng isa.
In addition to what my groupmates have reported, since we all know that flotation is the method of foam separation which involves the removal of solid particulate material, flotation has 7 classifications. These are ore flotation, macroflotation, microflotation, precipitate flotation, ion flotation, molecular flotation, and adsorbing colloid flotation. So let's discuss first the ore flotation. Ore flotation composed of 2 parts. These are the tailings and the concentrate. Usually, tailings are the undesired material, or they are the underflow. These are the solids that usually sink. While concentrates are the solids that are being floated. Usually, these are the desired material. On the other hand, macroflotation is used for removal of macroscopic particles, while microflotation is the removal of microscopic materials. Usually these are microorganisms and colloids, and this is also called colloid flotation. Precipitate flotation also is used for removing precipitates using a collector, but this is not the precipitating agent. And ion flotation is used for the removal of surface inactive ions by using collectors such as skimmers, thus yielding an insoluble product which are called scums. While molecular flotation, on the other hand, is the removal of surface inactive molecules through the use of a collector, also yielding an insoluble product. And lastly, adsorbing colloid flotation is the removal of dissolved materials in piggyback, fashioned by adsorption on the colloids. And in flotation processes, first we discuss the flow diagram of a typical flotation process. This consists of mill, classifier, conditioner, rougher, cleaner, and scavenger. The first 3 units are not considered as flotation cells, but they are important for pre-treatment of the feed before flotation process. but we are going to discuss each unit. In the mill, it uses ball mill or crusher, wherein particles larger than mesh 20 are crushed to desired particle size, and the suitable size range for flotation process ranges from mesh 200 to mesh 20. Because if particles are too big, air bubbles would not be able to support the solid in the froth. On the other hand, in the classifier, particle size are being controlled before the conditioner unit. So the crusher sizes are brought back to the mill for further crushing, for further processing. And after that, it goes to the conditioner. In the conditioner, reagents are being introduced to coat the solids to be floated. After that, after the filming reagent coat the solids, it goes to the first or the initial rough separation done by flotation process, which is in the rougher. In the rougher, there are two product streams, the underflow and the overflow. Usually in the underflow, these are the undesired product, are called the tailings, and the overflow, this is the desired product, which is the concentrate. The undesired product, which are the tailings, goes to the scavenger, wherein the desired material is further removed from the undesired material of the tailings. So the removed desired material goes back to the rougher for further separation, and the undesired material are now becoming waste, which are called the final tailings. And also in the rougher, the concentrate goes to a cleaner, in which the concentrate is being further fed from the tailings. So the separated tailings goes back to the rougher for further separation, and the product is the final concentrate. So thank you.